okay? And the other is this tube that it's kind of not vertical, it starts vertical and then it goes like this, okay? Now the question is, what is the difference between those two tubes? Piezometer, you should know. What is a piezometer, you think?
It's just the pressure.
Just the pressure. Now, actually, which pressure you think it measures from the what you see there in the equation?
Just
P over.
P over
The pressure head.
the pressure head. So actually, I will use now the term from the previous slide so I can make my claim here more clear. So this is your static pressure. Let's add this thing. Static pressure. What does that mean, static pressure? If I have a bucket of water, like we did in the not previous chapter, we did it from the beginning, and at this point, let's say, how much is the pressure at this point?
The height.
The height times
Delta Z.
is the density, gravity, and height, or gamma and height. Now, this is, again, this does not move, so you have a bucket of water, so this is static pressure. Okay, this is a static pressure. Okay. Now, what's so special about the other tube? Who can tell me? What is why the other tube looks the way that it looks there?
how to adds the velocity.
It adds the velocity. As you can tell, the tube is rotated here and actually is aligned with the direction of the flow. So actually this tube now will measure what, you think?
The speed,
No, just
velocity,
not,
pressure.
and not exactly. It will measure two things. It will measure the summation of the actual pressure head, which is the static pressure, but it will also measure the velocity head, which is the dynamic pressure. So let's write down about the velocity head, just to make it clear with this sketch, that this is dynamic pressure. I mean, you don't see the pressure in terms of a P, like P over gamma, but there is still pressure due to V squared, due to the velocity head. So again, you have two tubes, the piezometer upstream and the so-called pitot tube. Yeah, this is the pitot tube. You see it makes this weird 90 degrees, almost 90 degrees angle here, and here's a little opening here. That's what they call a stagnation pressure hole here. And then if you measure the flow with this, if you put this tube here, so what's gonna happen is water is gonna enter here and it's gonna race to this point, okay? So it's gonna race to this point. Now, before that, at the same location, you have the piezometer. So the water level is gonna raise to this point. Remember that the piezometer measures what again?
Static pressure.
P over gamma. So this is your P over gamma. The other device, this tube, the pitot tube, measures what? P over gamma plus V squared over 2G. So the difference between the two elevations will measure what? Just the V squared over 2G, just the velocity head. Now you're gonna tell me why it's so important. So actually, what can we do using those two, the piezometer and the pitot tube, or the pitot probe? We can measure what using those two tubes?
We can measure the pressure and the velocity.
Well, yeah, the pressure and the velocity, or if I just care about the difference between the two, I will measure directly which quantity there. The velocity of the water in the pipe. So this is an indirect way to measure your V in your pipe. So let's say you don't know how much is the speed of the water into the pipe. Well, if you use those two tubes and you install them properly here, one measuring at this point the pressure head and one more measuring at the same point the pressure head plus the velocity head, the difference between the two readings on this tube and on this tube will give you the actual velocity of the flow. Actually, they're not going to give you the velocity, they're going to give you the v squared over 2g. Any questions about that? And this is the equation actually that you can use to calculate the velocity given the pressure here at the tube, that's the stagnation pressure, the actual P, the static pressure, and the test of the water. So please write down this formula in your equations.
Would that one only work for water in a pipe? Or does it work for everything?
Everything. Everything. It can be oil, it can be anything. Actually, the same principles apply for flow in how you call them in our human body. You have the blood, the vessels, yes. Same principle is applied there. Same fluid mechanics principles. Obviously, the density is different. Now, obviously, here just some observation there. They need to be those tubes that they measure the pressure. They need to be installed correctly, so they give you the correct reading, let's say, of the static pressure. Okay. So, for example, here, or here, those things will give you a wrong indication, and the correct indication is this one.
Which one is the stagnation pressure?
Stagnation pressure is at the, you see if I go back, they call it the stagnation point, is right here at the tip of the tube, like just right here, when it enters into the tube. Okay? So that's what it is.